Hello everyone, this is Ritvika and Ashish presenting you our project Health Vita, the ultimate healthcare monitoring ecosystem. So to begin with, we have the introduction followed by the schematic, then the components and software used. Then we have the different sensors that we have used in our project, following which we'll show you how the entire thing gets connected to IoT. After that, we'll explain what Thingspeak is, following which we have a demonstration of a few sensors which we collect the data and do the analysis for. We've also made use of a Wio Terminal, which is a device by Seed Studio. Finally, we'll present to you the future prospects and we have the references. The demand for smart wearables has been driven by increasing focus on active patient engagement and patient-centric care, growth of high-speed network technologies for IoT connectivity, and the surging need for the adoption of cost control measures in the healthcare sector. The integration of IoT in the healthcare sector has significantly enhanced telemedicine by enabling providers to offer great quality of care as reliable as in-person treatment modalities. In the wake of the COVID-19 pandemic, there has been a massive surge in the adoption of telemedicine in healthcare service, which is also fostering the need for such devices. Health Vita is set to revolutionize the healthcare-based IoT paradigm. Wearable devices with sensors are the need of the hour in the healthcare industry, tracking an individual's activities throughout the day and through the night without much interruption and discomfort. This is the schematic of our project. We collect data using sensors. This is followed by data acquisition, data stream, cloud computing, data analytics, and application. So to begin with, we have our sensors, which are temperature sensor, pressure sensor, pulse rate sensor, SpO2, which is oxygen saturation sensor, ECG sensor. These are the vitals that are tapped in by the sensors. After data acquisition, we have data streaming, which is done with the help of a gateway. In our project, we've made use of Wi-Fi as our gateway. We could also use LoRa long range as one of the gateways with the help of our Wio Terminal, but we chose to use Wi-Fi using the ESP8266 module, which is the Node MCU. Following this, we have made use of cloud computing with the help of Thingspeak, a software by MathWorks, and the data analytics is done in the very same software, following which the data that is obtained is sent forth to different handheld devices.
So these are the components used, and we have used three softwares. One is Arduino IDE, then we have used Tinkercad for some simulations and testing, and the Thingspeak for the cloud servers. So this is the code for BMP180 sensor. This is BMP180 sensor, which measures barometric pressure, altitude and temperature. So this is the code given for this, and we get the corresponding readings after every 5 seconds. This is the code for Max30102 Sensor. This is a Max30102 sensor, which is an SpO2 plus pulse sensor. So this is the code which we write, and the output is like whenever we touch the sensor, the values will vary accordingly whenever it senses some pulse. This is the code used to connect Node MCU with the ADXL335 sensor. This is Node MCU ESP8266 with an ADXL335 sensor. So when we connect this is the code which we require, and then when we run this, it will compile and it will show how it's connecting. It's a bit slow. Now when we go to the serial monitor, we will get the readings for x-axis, and similarly we can get it for all the y and z axis. This is the code for AD8232 sensor, which is an ECG sensor. This is the AD8232 sensor, which is an ECG sensor, and this is the code which we write for it, and this is the reading which we get when we place the red and yellow on the hands of a person, and it will fluctuate according to the ECG of the person. This is the code for MPU 6050 sensor. This is MPU 6050 sensor, which is a gyroscope and accelerometer, along with it tells the temperature too. So this is the code for this, and this is how we get the output XYZ rotation and acceleration.
So our primary goal is to connect sensors to the ESP8266 module, which is the Wi-Fi module, and this Wi-Fi module gets connected to the local Wi-Fi network. So this is the code for connecting the Wi-Fi module with the sensor, and here we are making use of Thingspeak, which is a cloud platform by MathWorks. So here any change in the data sensed by our sensor locally will cause a change in the cloud analytics. So this is how we're doing it. So here there's a change. We are manually trying to change the temperature, and as you can see here right now, just now, you can see that there's a change. I tried warming up, and there's a change. So this happens over the cloud. So this is how we do it for the other sensors.
Thingspeak is an analytic IoT platform that allows to aggregate, visualize, and analyze live data streams in the cloud. Thingspeak provides instant visualizations of data posted by devices to Thingspeak. With the ability to execute MATLAB code in Thingspeak, we can perform online analysis and processing of data as it comes in. Thingspeak is often used for prototyping and proof of concept IoT systems that require analytics. This also enables sensors, instruments, and websites to send data to the cloud where it is stored in either a private or a public channel. Once data is in a Thingspeak channel, data can be analyzed and visualized, calculated, and interacted with social media, web services, and other services.
So the next step is, once we perform the analytics, it is here in this one we have used the SpO2 sensor, which is the oxygen saturation sensor. This can be used for measuring the SpO2 level and also the heart rate of a person. So we can also locally plot a graph on the serial monitor, and as you can see, this is no way connected to this, so it happens entirely over the cloud. So here we get the heart rate and the SpO2 levels in our Thingspeak channel. Okay.
The Wio Terminal is a SAMD51 based microcontroller with wireless connectivity powered by Realtek RTL EE701DN that's compatible with Arduino and MicroPython. It runs at 120 MHz, 4 MB external flash, and 192 kilobits of RAM. It supports both Bluetooth and Wi-Fi, providing backbone for IoT projects. This is equipped with a 2.4 inches LCD screen, onboard IMU, microphone buzzer, micro SD card slot, light sensor, and infrared emitter, having a range of 940 nanometers. It also has two multifunctional Groove ports for Groove ecosystem and 40 Raspberry Pi compatible pin GPIO for more add-ons. As you can see, we have used this as an LCD device. We could also use this as a microcontroller in itself, but since we've made use of Arduino, we have used this as an additional display device. So here, the Wio Terminal is used for displaying the vitals, which are temperature, SpO2, and pulse. These have been calculated for a particular interval of time, and these keep changing with respect of time. So that's how we have used this in our project. But yes, the Wio Terminal does have a lot of other applications as well.
Future prospects are we can make use of this to make wearable devices. Further, we can introduce machine learning to like train models and detect some diseases by setting values and thresholds. Then the recent advances in the sweat-based sensing will be a great advantage, as the human sweat contains a lot of relevant data which can help us find blood sugar, blood pressure just by the sweat. And then we can add other technologies such as capacitive sensing, which is shown in the video.